The universe is a vast and ever-changing place. Galaxies, those majestic islands of stars, are not stationary. They move and interact, often with dramatic consequences. In our corner of the universe, a cosmic collision is inevitable. The Andromeda Galaxy, our nearest galactic neighbor, is on a collision course with our own Milky Way. This might sound like a scene from a science fiction movie, but it's a real cosmic event. Don't worry though, it won't happen for billions of years. Nevertheless, the prospect of two galaxies colliding is mind-boggling. It's a reminder of the immense scale and power of the universe we live in. The collision will reshape our galactic neighborhood. It will also create a dazzling display of celestial fireworks. This event will forever change the night sky as we know it. To understand this cosmic collision, we need to grasp the basic movements of galaxies. Galaxies are not just randomly scattered throughout space. They are drawn together by gravity, forming clusters and superclusters. The Milky Way and Andromeda are part of the local group, a collection of about 54 galaxies. Within this group, Andromeda and the Milky Way are the two largest members. They are engaged in a gravitational dance, pulling on each other with their immense masses. While the universe is expanding, with most galaxies moving apart, the Milky Way and Andromeda are exceptions. They are moving towards each other at a speed of about 250,000 miles per hour. This inward movement is driven by gravity. The immense gravitational pull of Andromeda and the Milky Way is overcoming the expansion of space between them. This sets the stage for their eventual collision. Astronomers estimate that the Andromeda-Milky Way collision will occur in about 4 billion years. That's a long time from now. To put it in perspective, it's roughly the same amount of time that life has existed on Earth. Predicting the exact timing of such a complex event is challenging. However, astronomers use sophisticated computer simulations to model the movements of galaxies. These simulations take into account the galaxies' masses, speeds, and trajectories. Based on these models, the 4 billion year time frame is the most likely scenario. Of course, there's always a margin of error in such predictions. The collision could happen a bit sooner or later, but one thing is certain, the collision is inevitable. When Andromeda and the Milky Way collide, it won't be a head-on crash. Instead, the two galaxies will pass through each other, their stars and gas clouds interacting in a complex gravitational dance. This initial pass-through will disrupt the spiral arms of both galaxies, creating long tails of stars and gas. Over billions of years, the two galaxies will continue to interact, their gravity pulling them back together. This back-and-forth dance will continue until they eventually merge into a single giant elliptical galaxy. This new galaxy will have a more rounded shape than either the Milky Way or Andromeda. It will be a cosmic blend of the two original galaxies. The Milky Way, as we know it, will cease to exist. It will be transformed into something new and different. Section 5: Stellar Nurseries, Cosmic Fireworks, and the Birth of Stars. The collision of galaxies is not just about destruction and chaos. It's also a time of intense star formation. When galaxies collide, their vast clouds of gas and dust are compressed and disturbed. This compression triggers a burst of star birth. The Milky Way-Andromeda collision will create countless new stars, illuminating the night sky with their brilliance. These stellar nurseries will be scattered throughout the merging galaxies, adding to the cosmic spectacle. This burst of star formation will have a profound impact on the evolution of the newly merged galaxy. The new stars will enrich the galaxy with heavier elements, contributing to the complexity of future generations of stars and planets. Section 6: Our Sun's Fate, a new neighborhood for the solar system. What will happen to our solar system during this galactic merger? The good news is that our sun and its planets are unlikely to be directly hit by another star. The distances between stars are vast, even during a galactic collision. However, that doesn't mean our solar system will escape unscathed. The gravitational forces from the merging galaxies will disrupt the orbits of stars, including our sun. Our solar system could be flung outward, farther away from the galactic center. Alternatively, it could be pulled inward, closer to the action. In either case, our night sky will change dramatically. The familiar constellations will be rearranged as stars are scattered and shifted. The Milky Way, as we know it, will be gone, replaced by a new and unfamiliar celestial tapestry. Section 7: Ripples through space-time gravitational waves from a galactic merger. The Andromeda-Milky Way collision will be a cataclysmic event, releasing an enormous amount of energy. This event, predicted to occur in about 4.5 billion years, will be one of the most spectacular cosmic events ever witnessed. The gravitational pull between these two massive galaxies will draw them closer and closer until they eventually collide. This energy will not only be released in the form of light and heat but also as gravitational waves. These waves will ripple through the fabric of space-time, carrying with them the story of this monumental collision. Gravitational waves are ripples in the fabric of space-time, predicted by Einstein's theory of general relativity. They are essentially disturbances that travel through the universe, much like the ripples created when a stone is thrown into a pond. These waves are produced by the acceleration of massive objects such as black holes or colliding galaxies. When these colossal entities interact, they create powerful gravitational waves that can travel vast distances across the cosmos. The collision of Andromeda and the Milky Way will generate powerful gravitational waves that will spread outward at the speed of light. These waves will carry information about the mass, speed and distance of the colliding galaxies, providing a unique glimpse into the dynamics of such events. While we currently lack the technology to detect gravitational waves from such a distant event, future generations of astronomers might be able to observe these ripples from the galactic merger. Advances in technology and observational techniques will likely make it possible to detect and study these waves in great detail. These observations would provide valuable insights into the dynamics of galaxy collisions and the nature of gravity itself. By studying the gravitational waves from such events, scientists can learn more about the fundamental forces that shape our universe and the intricate dance of celestial bodies. Section 8. Life Interrupted, Cosmic Upheaval and the Search for Other Earths. The universe is a vast and mysterious place filled with wonders and dangers alike. One of the most intriguing questions we face is whether life can endure the cosmic upheavals that shape our galaxy. The Andromeda-Milky Way collision will undoubtedly be a time of great upheaval for our galaxy. But what about life? This colossal event, set to occur in about 4.5 billion years, will reshape the very fabric of our cosmic neighborhood. Could life survive such a cosmic event? The answer is uncertain. Our planet, with its delicate atmosphere, might face unprecedented challenges. On the one hand, the collision itself is unlikely to directly threaten life on Earth. The vast distances between stars mean that direct impacts are improbable. As mentioned earlier, the chances of our solar system being directly hit by another star are slim. However, the gravitational forces at play could still have significant effects. However, the long-term effects of the collision could pose challenges. The increased gravitational interactions might disrupt the orbits of planets and other celestial bodies. The increased radiation from star formation could alter planetary atmospheres or even strip them away entirely. This radiation could come from newly formed stars, or from the energetic processes involved in the galactic merger. On the other hand, the galactic merger could also present new opportunities for life. The mixing of gas and dust from the two galaxies could create fertile grounds for new star systems to form. The mixing of gas and dust from the two galaxies could seed new star systems with the ingredients for life. These new star systems might host planets with the potential for life to develop and thrive. And the vast distances involved in a galactic collision mean that life on other planets, if it exists, might not even notice the event. The search for other Earths continues as we strive to understand our place in the cosmos and the resilience of life itself. Section 9. A Cosmic Finale. Legacy of the Andromeda-Milky Way Collision. The Andromeda-Milky Way collision is a reminder that the universe is not static. It's a dynamic, ever-evolving expanse where nothing remains the same for long. The night sky we gaze upon today will look vastly different in the distant future. It's a place of constant change where galaxies are born, evolve, and sometimes collide. These cosmic interactions are not just random events, they are part of the grand tapestry of the universe, woven over billions of years. While this particular collision is billions of years in the future, it offers a glimpse into the long-term fate of our own galaxy. The slow dance of Andromeda and the Milky Way is a prelude to a spectacular cosmic event. The merger of Andromeda and the Milky Way will create a new and magnificent galaxy, a cosmic blend of two galactic giants. This new galaxy, often referred to as Milkomeda or Milkdromeda, will be a testament to the power of cosmic forces. This new galaxy will be a testament to the enduring power of gravity and the ever-changing nature of the universe. The gravitational forces at play will reshape the stars, gas, and dust, creating new stellar nurseries and possibly new planetary systems. As we contemplate this cosmic event, we are reminded of the vastness of space and the incredible processes that shape the universe around us. The scale of these events is almost beyond human comprehension, yet they are fundamental to the story of the cosmos. The Andromeda Milky Way collision is a story that will continue to unfold for billions of years, long after our own sun has burned out. It is a poignant reminder of the transient nature of our existence and the enduring legacy of the universe.